So in this problem right here, Tree, our little mascot, throws a baseball 3 meters up into the air. And at this point, its speed is 10 meters per second and it has a mass of 0.15 kilograms. And the first part tells us to find v of t of baseball at time t. Now first you have to consider this. This is acceleration of the baseball, which is the rate of change of velocity, as acceleration is v over s. Now using Newton's second law, we can get F equals to ma, force equals to mass times acceleration. And replacing the value of acceleration, we can get force equals to mass times derivative of v. And according to Newton's second law as well, the force of gravity acting on the baseball equals to minus mass times gravity, and it is minus as the baseball is going downwards, not upwards. And also according to Newton's second law, the force acting on the baseball equals to the force of gravity acting on the baseball. And so we can replace these two F's for their other values, which we get minus m times g equals to m times derivative of v. We can cross out the m's on both sides and we get minus g equals to the derivative of v with respect to t. Now another important thing to take note of is the initial velocity of the baseball. What is initial velocity? Initial velocity is the velocity of the baseball when t equals to 0. And we can notate this as v with 0 in the brackets or v0. And we know the value of v when t equals to 0, and that is 10 meters per second. Now that we know both of these important informations, the first one being initial velocity is 10 meters per second, and the derivative of v with respect to t equals to minus 9.8, we can start solving for vt. First step is to find the antiderivative. The antiderivative is when we try to find the original function from a derived function. So basically it's working in reverse. So we know that the derived function is basically minus 9.8, which equals to minus 9.8. 1 times minus 9.8 times t to the power of 0. And working in reverse, we add the exponent by 1 and remove the coefficient, which is 1, and we get v of t equals to minus 9.8 times t to the power of 1, we just don't write it here, plus c. Now this plus c comes from the fact that when we derive functions, the constants basically disappear, and they are not there anymore, as this is basically t to the power of 0. You just don't write it, and when you move 0 to the front, it equals to 0 times c, which is 0. So when you derive it, it's not there, but we always have to consider it when finding the antiderivative. So next we must solve for c. So we know that v of t equals minus 9.8t plus c, and so we also know the initial velocity, which is when t equals to 0. So we substitute t for 0 here, so which equals minus 9.8 times 0, which is 0, plus c. And we know that v when t equals to 0 is 10, so we get 10 equals to c. Now we put it all together in one equation, we get v of t equals minus 9.8t plus 10. Now we can use this equation to find out the velocity of the baseball after 2 seconds. So we have this equation that we got before, and all we have to do is replace t with 2. So t equals to 2. So v, when t equals to 2, equals minus 9.8 times 2 plus 10. So its velocity after 2 seconds is minus 9.6 meters per second.